Hello, we are going to discuss time series analysis today. Time series relates to one of the very primary concepts of forecasting technology. If you are working in a particular field, like suppose say productivity, and you want to establish a particular relation between productivity of past few years, then we want to have a particular kind of relationship that is required to be existing within the data that has been collected for that purpose. For example, if the production of 1990 is 100 tons of certain commodity, 91 it is given till 95, suppose say. So we have given the productivity figure starting from the year 1990 till 95. On the basis of that, we can establish either a linear or a non-linear relationship between the data. Once a relationship is established, we will be in a position to conclude the productivity that can happen, that is expected to happen in suppose say 2003 and 2012 and 2023. On the basis of similar kind of growth, we need to establish a direct relationship between productivity and the year number time component. In business and economics, time series is one of the important concepts and which is very frequently used in demand forecasting or business forecasting. Time series can be defined as an ordered sequence of values of a particular variable at equal interval, an equal spaced time interval, suppose per year, per quarter, per week. So time series relates to a particular spaced interval. From economic situation point of view, if it relates to an individual firm or an industry or as the national economy as a whole, we can observe a continuous movement of economic activity. In order to describe this flow of economic activity, the statistician is going to use time series analysis. Time series means a set of observations occurring an activity against backdrop of different periods of time. The times are normally of equal interval like hourly, weekly, yearly or quarterly. The duration of the time period is equally spaced. So the distance between the first and second time period is exactly equal to the distance between the second and third time period. On the basis of these time periods, we are able to establish either a linear relationship or a non-linear relationship. But right now we are concerned about the linearity of the equation, linearity of the variables. One of the examples of time series data is profits earned by a company for each of the past financial years, which are 5 in numbers. Workers employed by a company for each of the past 15 years. Number of students registered for MBA or CA examination for past 5 years. The weekly wholesale price index for product for last 30 weeks. Number of fatal road accidents in Delhi in each day for the past 2 months. So these data, you can clearly see that the data period is having an equal amount of interval. The distinction of space between two common data is equal and remaining equal. If the data is related to the periods are not equal, there is a difference of time period, for example, the first data is of 1 month, the second data is of 1 year, then it will be pretty difficult for us to calculate and encumber a linear relationship between them. The application of time series is twofold. We have to obtain an understanding of the underlying forces and structure that product of the observed data. We have to fit a model, we have to devise a model which can fit the data which is given to us. Like I have already said that either we are going to use a linear model or a non-linear model. Non-linear model is not right at the discussion stage right now, so we're concentrating on various linear models. Linear model can be defined as a straight line equation or a circular relation. So we have to fit a model and proceed to forecast, monitor, and find and feedback about the expected valuations, and then we can have a feed forward control. Is given with their expected frequency, and we have to calculate the expected frequency from the observed frequencies. If the observed frequency is greater than the expected frequency, then the association is positive. If the observed frequency is less than the expected frequency, the association is negative. In case the observed and expected frequencies are almost identical, then the two attributes are independent of each other. The main drawback of this method, the frequency method, is that we cannot find the degree of association. Even if we are able to find any association, it is one kind of association, whether it is positive, negative, or independent of each other. We don't know what kind of one degree of association the variables are having. Given the following data, find out whether the attributes A and B are independent, positively associated or negatively associated. A is given to be 15, value of B is given to be 15, A multiplied by B is 15, N is 50. We find A into B by N, the expected value to be 15 into 25 by 50, that is 7.5. AB is 30, which is greater than 7.5. We follow the following principles. A into B must be greater than A into B divided by N. If this happens, that AB is greater than A into B divided by N, then there is a positive association. If it is less than, there is a negative association. Because AB is 30 and it is greater than 7.5, there is a positive association between A and B. So we conclude that the expected values are less than the observed values. So observed values are in positive relationship with the expected frequencies and expected values. We have taken another example. Given the following data, find out whether the attributes A and B are independent, positively associated or negatively. A is given to be 130. Alpha V, which is the opposite of 1 minus A, is 180. Alpha is 240. AB is 430. We follow the following principles. That A plus alpha is N. If N is equal to A plus alpha, A and alpha is given. So N is 310 plus 240, that is 550. AB plus alpha V is B, which is 430 plus 180 is 610. So B is 610. So our observed frequency is A into B by N, 310 plus 310 multiplied by 610 by 550, that is 343.8. AB is given to be 430, which means AB is greater than A into B divided by N. It means A and B are positively associated because they complement the principle that AB must be greater than A multiplied by B divided by N. So these values are positively associated and are dependent upon each other. The next method is proportion method. Two attributes A and B are said to be associated if the proportion of A's in the B is the same as amongst betas. Also, if the proportion of betas, then there is a positive association between A and B, and if less than that, A and B are negatively associated. We can summarize them. If AB by B is equal to A into beta by beta, then A and B are independent because they are almost identical. If AB by B is greater than A into beta by beta, then A and B are positively associated. If AB by B is less than that of A beta by beta, they are negatively associated. Equal, independent, greater, positive, and lesser, negatively associated. Still, there is no confirmation about the degree of association. In the proportion method also, we fail to find the kind of association. Rather, we fail to find the degree of association, even if we are able to ascertain the kind of association, positivity, negativity, or independency. For example, in a study of 200 persons, 120 are poor. Out of 100 persons who suffer from TB, tuberculosis, 50 are poor. Find the kind of association between poverty and TB. Suppose A represents the attribute poor, A is 120, B represents the attribute of TB, that is 100. Total number of observation is 200, and AB is 50. Poor people suffering from TB. We can summarize the two-way table as A is 50, that happens in the B, AB. So alpha, which is not A, the total number of TB patients are 100. So total minus B is alpha, 50 again. A plus beta is 120, so beta is 70. Alpha plus beta is 100, so beta is 30. So which means we have to calculate all the three. AB by B is 50 by 100, that is 0.5. A beta by B beta, A beta by beta, 70 by 100, that is 0.7. So you can see clearly that AB by B is A beta by beta. The relationship is that AB by B is much lesser than that of A into beta by beta. 0.5 is less than 0.7. So by the rule, A and B are severely negatively associated. They are in no way positively or independent of each other, which means if one of them happens to be increasing, the other's value is going on to decrease. The next methodology is Yule's coefficient, which is the most popular measure of association. The main advantage of Yule's coefficient is that it not only tells about the kind of association, but also the degree of association. So this is the first coefficient of association which is providing us the degree, the kind of association that we have. For two attributes A and B, the class frequencies can be displayed in a two-way table, that of the proportion method. A and B, then beta, AB, alpha B, A beta, alpha beta, and BB, A alpha and N. Total is A, total is alpha, and total is N. We can summarize that in a question format. For the cell frequencies given above, the coefficient of association can be calculated as Q. Q is AB into alpha beta minus A beta into alpha beta divided by AB into alpha beta plus A beta into alpha beta. The value of Q lies between -1 and +1. If the value is greater than -1 but less than or equal to +1, there is a perfectly positive correlation. If Q is exactly -1, this is perfectly negative association. If Q is 0, two attributes are completely independent of each other. We prepare the two-way table for the frequencies with two attributes A and B. If we are given that N is 100, N is 800, beta is 330, A is 420, and AB is 110. We can summarize that. AB is 110, beta is 330. So if beta is 330 and we are also given AB is 110, so which means out of 800, if you discount beta, then the first column, first row total would be 800 minus 330, that is 470. If you find AB to be 110, then alpha B is 470 minus 110, that is 360. Then out of 420, if you minus 110, you will get beta is 310. So A beta is 310 and alpha beta is complementing, it's 20. So by putting all these values, Q is equal to AB into alpha beta minus A beta into alpha beta, divided by AB into alpha beta plus A beta into alpha B. 110 into 30 minus 360 into 310, 110 into 30 plus 360 into 310, the value is coming to be minus 0.94. The value shown is falling between minus 1 and plus 1. This shows that there is a high degree of negative association between A and B. The value of Q lies between minus 1 and plus 1. There is a perfectly positive association between the variables. The measures of association refers to wide variety of coefficients that can be measured with the strength of relationship that exists. The strength of the relationship can be described in several ways. The word association particularly measures the strength of relationship for at least one variable with that of the other variable. The variables may be dichotomous in nature, generally nominal or ordinal in scale, which means if you keep on comparing the various data that is being given to us, then we should be in a position to calculate the measure of association. One of the finest example of testing the measure of association is the chi-square test, which we have already discussed previously. We'll keep on continuing to test the data, test further. I hope you understand and you complement by studying. Next time we discuss something else. Till then, bye bye. Thank you very much.
Hello. We are going to discuss today production control. That is a part of production control and material management subject. Let's see what production control is and let's see how we go about. Now here, as far as the subject is concerned, we are going to discuss that is what is production control, which is we call it as factory's nervous system. See, everything is okay, but unless the production control is not there, which is a nervous system of the factory, we cannot carry on without any problem. All operations are carried out and parts and components put together into finished products. So what is happening in this one? We are putting everything, all materials is taken in consideration, all materials is assembled at various different places, and ultimately we find the product is ready. That is what the production is. Now it's only production control which sends the necessary continuous stream of directions to all the parts from the factory. Now it is only through production control everybody is functioning, every worker is doing the job, and ultimately we find that whatever things are happening, the the work is going on, and ultimately we find the product is completed accordingly here. Then coming to production control is defined as design and use of systematic procedure for establishing plans and controlling all elements of factory. Now what is how do we define that production control? The production control is very important issue. It is based on the design, it is based on the procedure which has been laid down, system as procedure which has been laid down, and everybody is functioning as per the duties and responsibilities, and that's what we call production control, and we get the results what we achieve. Now production control involves the following. What are those steps here? Which are that is designing a sound systematic procedure. Now no production control is possible or will be successful unless we design a system or design a procedure which should start from A and carried up to Z. And keeping that in mind here, that is what we say here should be sound and systematic procedure. And without that, it is not possible to carry on. Second issue here is properly using system that has been designed. Now system, the program, the control which has been made, I'm talking the system which has been designed, it should be utilized in a manner so that the utility of the system is fully under control. Now another point which is to be taken into consideration is a follow-up procedure for determining how closely the plan is followed. Now we have made the production control, we have made the system, we have made the design, we have done everything. But unless we don't follow, unless we don't see, unless we don't monitor, then the production control is not complete and the system will not be able to function accordingly. That's what we must do that. Now a next where is a means of regulating to meet the plan's requirement. Now here we have designed a system, we have further system, and things are carrying on, and that is where we must make sure that the plant's requirements are met by the system which has been designed and the production carries on. Now here, after discussing what the production control is, let's come to the need for production control. What are the needs? Why it is required? Why do you want this? Here we are talking here to ensure proper transformation of raw materials. After all, what is production control? We have raw material, we have the manpower, they all do their duties, and ultimately the raw material is collected, it is assembled at various places, and then the raw material which is assembled at various places is making a finished product. That is what we say proper transformation of raw materials is transferred for the finished product. We anticipate difficulties with possible solutions in advance. Now here we have made a system, we have designed a system, and then we will find we may come across certain problems, certain difficulties, and that must be taken into consideration prior to making the system. The system should be so foolproof so that if there are difficulties, we must be able to find a solution in advance and the control is taken into consideration. To maintain programmed production and ensure quality here, whatever we have designed the system, it must be maintained and it must be ensured that the things are going on, everybody is doing its duties and responsibility, and as a result we get the quality product at the end. To minimize the inventory control, now if the system design has been perfectly alright, if there are no drawbacks, if we are taking care of all the precautions, then we will find here the inventory cost will minimum, because the major cost in the finished product is the inventory cost. Manpower and inventory, these are the two costs, and inventory cost means material cost, so we must make sure the inventory cost is minimized. That should be the design of the production control. To ensure the economical operation of the factory, now in keeping in mind here, we must make sure that the system which has been made is functioning economically, and as a result we are taking care of that way so that the cost is reduced and the quality products is produced accordingly here. To meet the customer's requirement, which may change very frequently by the production control. Now here a customer has given an order for a particular product. Now that product design, if it has to be changed, if it has to be revised, it must be taken into consideration, and as a result we must make sure the requirement of customers are taken into consideration, and accordingly the production control system can be modified here to ensure proper design of product to meet the customer's requirement. Again, the product which has been designed, the particular things have been taken into consideration, the design has been produced, and we are going to work on that way. So we must make sure that the design which has been formed, it must be streamlined, and it must be sure that we are meeting the customer requirement with that. Now here, coming after knowing what the production control is, let's come to the here need. We have to discuss introduction.